Hello, good evening. Today we're going to talk about specific heat. Specific heat is the amount of energy needed to raise a substance 1 degree Celsius. So let's say you have a piece of iron and you're trying to heat it up and you're going to add some energy to it. What do you measure energy in? What did you say? Did you say joules? If you did, you got it correct. So you add the energy measured in joules to an object or a substance, and if you add enough of that energy, then you're going to raise that temperature 1 degree Celsius. Now we always use Celsius in science, and I know you're thinking, well, we just talked about Kelvin. Yes, you can use Kelvin in science also, but you can just go ahead and convert that Kelvin to Celsius for purposes of specific heat. So what you do is you take the specific heat of a substance, and that's a number that we have that's given for all different things. So everything has its own special number, just like you have a student number, and that special number is its specific heat number. And what that means is as follows. Let's look at iron. Iron has a specific heat of 0.45 joules to the gram degrees Celsius. Now what does that mean? That means if you have 1 gram of iron, you have to add 0.45 joules to raise that temperature 1 degree Celsius. So for every degree Celsius you want to add to it, you have to give it 4.5 joules of energy for every gram that it has. Now you're probably looking at this and thinking, wow, iron's pretty low to, compared to water. Yes, it is. Water is pretty weird. You see, water we often think of can easily get hot, easily get cold, that kind of a thing. But it actually takes a lot of energy to change the temperature of water. And if you've ever lived up north, you might know that when you see, the snow falling in the wintertime and you see chunks of ice and all that kind of stuff, that it will often take a long time for all that stuff to melt and go away in the springtime. It doesn't happen overnight. It takes weeks for it to happen. And that's because it takes a lot of energy to raise the temperature of water. So for every gram of water you have, it takes 4.186 joules to raise it 1 degree Celsius. So the more you have, the more energy it takes. The more mass something has, the more energy it takes to raise the temperature of it. And so like a small ice cube is not going to take that much energy to raise this temperature. But a huge iceberg will, because it has more mass. So that's what specific heat is. It's the amount of energy needed to change the temperature of something. Now, if we look at this, Q equals Cm delta T. That is the formula for specific heat. So you should stop the video right now and write this formula down, because this formula is very important to know. Let's take a moment to talk about it. You got a bunch of letters. You got a triangle. You got an equal sign. It's pretty confusing when you first look at it, but really it's not. It's very simple. Q is equal to the amount of heat or amount of energy needed to change temperature. Then we have equals, and then we have 3 numbers multiplied together in the form of variables. Let me talk about those. C is specific heat. It's what I just showed you. So when we talk about water, if you look down here towards the bottom, you can see that water has that 4.186 joules to the gram per degree Celsius. So basically that is the number you would put in for C. Now one thing I want to talk about here real quick is that if you look at the units for specific heat, we have joules, gram, Celsius. That means that over here, that has to be in joules. Over here, the M is mass, and if this number is in grams, then the mass has to be in grams. Over here in temperature, if I have Celsius over here, then I have to have Celsius over there. So again, you have joules, grams, and degrees Celsius. Now we can give this number if we wanted to say how many joules it would take to raise 1 kilogram 1 degree Celsius. I would call that 4,186 joules to raise a kilogram 1 degree Celsius. So by the same token, that should also be in kilograms. So if this was in kilograms, that would be in kilograms. Okay? So when we talk about that, that's what we have going on there. We have those numbers have to match in terms of their units. Now, again, C is specific heat, M is mass, and then over here we have delta T. I know that you're not familiar with delta. What it is a Greek letter that represents change. So together, delta T means change in temperature. So what we're thinking about here is, as we look at this, don't think of the delta and the T as being separate things. Think of them as being one thing conjoined together. If we put T here for temperature, that would not work, because this would not be equal to these two in temperature multiplied together. It's the change in temperature that matters. So let's look at that and how this formula would work if I gave you a problem. So let's say I gave you this, and I wanted you to figure this out, okay? So here I have the specific heat of iron as being 0.45 joules to the gram degrees Celsius. So if I was going to find out what the change in temperature would be of this, okay, let's look at our other information. I'm going to give you the mass of the iron. The mass of the iron is 10 grams. And the current temperature of the gram is 100 degrees Celsius. But that doesn't really matter. We don't really care about that. What we care about is how much energy is going into this substance, which is right here, the specific heat of the substance, and then the amount of mass, so 10 grams. So I would multiply 0.45 times 10, which would give me 4.5. So when I multiply those two together, I have 4.5 if I were to simplify that. So 4.5 times the change in temperature equals 450 joules. So if you were to take, and you want to isolate this variable, you would take 450 joules is equal to 4.5 delta T. So divide both sides by 4.5. So 450 divided by 4.5 is going to be what? Did you say 100? So basically what would happen is delta T would be equal to 100. The change in temperature would be equal to 100. So here, if I had current temperature as already 100, and I added this much energy, then what would my temperature be? So I would take my current temperature and add the change in temperature. So my total will be 200 degrees Celsius. So basically what I'm doing is I'm just multiplying these three numbers together to get that. Now, if I already have that number and that number and that number, then I can work backwards to find what C would be. So you can always try to isolate a variable and rearrange the formula. But one thing I want you to know is that just like you can add energy, you can also take away energy. So usually what delta T is a positive number, in which case it means the temperature is going up. But if this number is negative, if I'm taking energy away, then that means the change in temperature would also have to be negative also, and the temperature would go down. So that real quick is just a way to explain what specific heat is. Take a moment to write that formula down, and today we're going to have some practice problems to work on. So again, what we're doing here, guys, is we're just taking these three variables and easily multiplying them together to find that. But, like I said, it's very seldom that you're just going to have to find this. Usually you're going to have to work backwards and find the mass, find the change in temperature, or in some cases find the specific heat, because we won't always give that to you. Stay tuned for your practice problems. Thank you, and good luck today.